In today's video, we are going to check the battery drain on a car battery. We will be connecting the multimeter in line with the battery cable, and to do that we need to disconnect the ground cable or the negative cable from the battery. I'm just going to move this cable out of the way, make sure that it doesn't touch any other metal surfaces or any other connectors or wiring. And then we will connect our multimeter in line. To test the current draw, we need to remove the red lead or the positive lead from the multimeter, and we are going to put it in the amp connection, and we will turn the dial on the multimeter to the DC amperage. That allows us now to connect the ammeter or the multimeter measuring the amps in line with your ground cable. The simple rule I usually follow is when you're connecting this to the negative post of the battery, the red lead goes to the negative post and the black lead to the cable side. You can now see the amp draw on this battery is 4.4 amps, which is quite a lot. Now, the modern vehicles today, they have all kinds of ECUs and control modules, lights, etc. that remain powered up for a little while. So once you connect the leads, you should see the initial current draw, but that will subside after a couple of minutes. So just keep it connected, keep an eye on the draw. You'll see it's already dropped down to 3.6. So now we just give it another couple of minutes and you should see it drop even further. Ideally, we want the current draw to be in the region of about 50 milliamps. So we're coming down on 300 milliamps now. It's come down substantially. We're dropping down to 120, 200 milliamps. That is already getting to a more acceptable range. But even at 200 milliamps, if your vehicle stands for a couple of days, it might still drain the battery down. Now we can see after a couple of minutes, we are right down to 48, 49, and then we're going down to 15 milliamps. So anything below 50 is probably a good place to be, I would say. Ballpark, this is looking good. So there is an initial current draw on this battery, but it looks like it comes down all the way to 15. So there's nothing wrong on a current draw on this battery. Right, so if you do have power issues, we now know, for instance, on this vehicle, that it is not caused by a current draw or an obvious one. There could always be something that kicks in later or intermittently. So it's not a foolproof test this, but at least you know how to look for that. So the next thing we're going to want to test once we tighten up the battery terminal again is to check if the alternator is charging this battery sufficiently while the vehicle is being driven or while the engine is running. Right now, so to test the alternator charging, we are going to put the red lead on the positive, the black lead on the negative. Now, important to note is we're selecting the voltage on the DC emblem, the two parallel lines, and the red lead is on the voltage side. With the engine off, you should have around 12.6 volts, which is when you start the engine up, the alternator voltage should go up to 14 and higher. Usually the regulators regulate the voltage up to 14.6 volts. So this one is running good at 14.2. We then turn the headlights on. I've selected the bright lights as well, so we can have maximum current draw from the lights to make sure that the alternator output is able to sustain that. You could turn other accessories on as well, or to make sure that the alternator is providing sufficient charge. Thank you for watching, and please subscribe to the channel if you enjoyed the content, and we'll see you next time.